Спасибо. Ну, мы больше ждать не будем, 15 минут подождали и хватит. Так, с чего начну? Сегодня у нас первую половину дня 2 потока, многие уже заметили это. Это отмечено также на бейджиках. Кто-то их... Что второй? Где второй поток? Второй поток, он начнется после того, как я тут закончу говорить, и будет вон там женский туалет проходите, и потом не останавливаетесь, да, и потом направо. Вот. Но если пойти через мужской, то можно обойти и тоже прийти. Так, Wi-Fi. Здесь есть Wi-Fi и очень сложный алгоритм туда зайти. Да. На колоннах там точно около столиков регистрации алгоритм этот написан. Так, это что еще? Ну, остальные вопросы сейчас по ходу рассмотрим. Так, мы очень хотим, мы тут почти за лайки работаем. В плане, что не мы получаем деньги за лайки, мы просто получаем лайки. Поэтому будем очень счастливы, если вы будете публиковать различные фотографии с нашей конференции и использовать вот эти вот хэштеги RSCONF, RSCONF 2016 и Rolling Scopes. Ну, можно все, можно по очереди, комбинируя и так далее. Так, спасибо. Тут пару слов о Rolling Scopes. Так, за последние пару дней много было вопросов, что такое вообще Rolling Scopes и почему бесплатно. В чем проблема? Да, то есть, да, просто. В основном это хобби какого-то количества людей, которые в свое свободное время и в несвободное, и в часть сна делают какую-то ерунду. Вот. А тут, может, есть участники первого митапа? Ну, ни черта себе у нас там. 300 человек только было, тут отлично, спасибо. Да. А все остальное свежая кровь, да. Сейчас будет свежая кровь. Да. В принципе, прошло почти скоро уже 3 года. Ну, темы не меняются. Angular, Ember, Primitive Tools, Web Components. Одно и то же мусолим, топчемся на месте, да. Все знают логотип наш, да, и вот его прообраз такой интересный. Саша Карлович когда-то нарисовал. Саша, где ты? Саша Карлович, ты есть тут? Был, шел. Ну, ладно. Что еще? Что нового прошло за прошлый год, за 15-й? У нас появилась возможность, точнее у нас и у желающих, привет, появилась возможность кого-то поучить. Мы занялись курсами какими-то открытыми, то есть это часть закрытые курсы, часть открытые, но так или иначе. А кто, может, посещал? О, кто-то даже посещал, отлично, спасибо. И мы продолжим эту традицию в 2016 году, если у кого-то есть вопросы именно, как попасть на эти курсы. То есть это там 40 лекций, начиная от самых основ, что такое HTML тег, там, что такое responsive дизайн, что такое там типографика, там, продолжая наследованием, там, использованием, когда начало, в марте. И, скорее всего, будет часть лекций мы проводили в Имагуру, а сейчас будем проводить что-то там, что-то вот прямо тут или в том втором потоке. Но только это в марте. Так, что у нас еще было за этот год? Мы начали и будем продолжать в этом году точно RS on Tour, то есть кто-то там уже был, да, то есть такой вот автобус, куда садятся фронтендеры и едут. В данном случае мы ездили в Брест, где был митап, нам очень понравилось. Мы провели митап, потом пошли на пиво, потом ходили в 3 часа ночи в Брестскую крепость. Нас не пустили. Мы пришли, посмотрели, милиционеры сказали, как бы не очень сейчас там ходить без света. Да, нас выгнали. Потом на следующий день все, кто проснулись, поехали в Минск с экскурсией по Минской области. А кто вообще ездил? Есть желающие, выжившие. Да, то есть потому что как бы там можно где-то потеряться. Что еще? То есть у нас всяких ивентов, видите, много. Кроме этого, мы съездили в Брест, и мы нашли в Бресте единомышленников. И здесь есть Александр Оргиш и Виталий Фокин. Не доехали пока, ну будут. 12 марта у нас будет в Бресте митап, но это будет уже обычный митап, который будет проходить в Бресте там, с какой-то периодичностью, может там раз в полгода, может быть чаще. Информацию. Мы начнем рекламировать этот митап на следующей неделе, где-то во вторник или в понедельник. Сайт. Да, сайт. Сейчас. Вспомни сайт. Пока мы для Бреста завели сабдомен. Так, Брест. Удивительно, правда? И он редиректит на Брест. Тоже хорошо. Но он пока редиректит на прошлый митап, а сейчас скоро начнет редиректить на новый. Но это будет обычный митап. А вот в конце марта или где-то в начале апреля мы уже планируем, почти спланировали митап в Гомеле. То есть это будет такой же автобус, который поедет из Минска. То есть не обязательно быть докладчиком, можно быть просто фанатом фронтенда или фронтенд-разработчиком, JavaScript-разработчиком, дизайнером, UX-специалистом. В общем, ну, если вам просто хочется послушать, что там говорят, или прокатиться на автобусе, посмотреть достопримечательности Гомельской области, то welcome. Регистрацию мы тоже, думаю, откроем где-то через неделю. Что еще? Вспомнил просто. Кроме Wi-Fi у нас есть синхронный перевод. Для того, чтобы... Кому он нужен, надо подойти на стойку регистрации и спросить, дайте наушник. Но вам придется... Да. А есть синхронный перевод? If someone wants... Okay. So if you need a simulation translation from Russian, from my speech to English, and you need to go to our registration deck and ask for it. But you need to provide passport or ID card. Thank you. Так, что дальше? RSCONF. У нашей конференции есть Code of Conduct. Там много текста, но вкратце никакого секса, наркотиков и прочих домогательств на конференции. Рок-н-ролл можно. Так, где туалеты? Есть несколько туалетов за кафе, и есть еще мужской и женский туалет около потока Б. Или просто за этой стеной. Да, и там мы зациклились, в общем, там. Где обед? У нас будут кофе-брейки, вы видели, да? Можно что-то съесть здесь, если кто хочет горячий обед, то есть горячего обеда не предусмотрено, там, или супа. Можно пойти по этому линку и попасть на Google форму, где выбрать или гороховый суп, или овощной. Там еще два вторых. Вы что-то выбираете, заказываете, пишете свое имя, фамилию, а потом во время обеденного перерыва просто надо сходить в соседнее здание, вот выйти отсюда, направо, и там будет небольшое, по-моему, этажное здание, куприща здание 4, куприща 1, здание 4, и, собственно, там купить свой обед и его съесть. Так как здесь все, к сожалению, закрыто. Что надо сделать сегодня? Где-то в обеденный перерыв привезут и поставят фотобокс. Кто был на прошлой конференции? А кто был вчера на воркшопе и выжил? А позавчера? А кто был уже и вчера, и позавчера, и на прошлой конференции? Не обманывай. Хорошо. Так, кроме этого, у вас есть буквы. Раньше они были Раньше они были на листиках, мы их вырезали и вложили в бейдж. В этом году мы прокачались, теперь они напечатаны, больше стали. В прошлый раз надо было собирать теги, да. Мы, если ничего более умного не придумали, как будем собирать. Нет, теги не будем собирать. Так, это неправильный тег. То есть так теги собирать не надо. Это не засчитывается. Так, да, вам надо просто взять ваши буквы. Вот в данном случае у меня L, какой-нибудь low dash. Кто еще на L может быть? Less. Lint, да. JS-lint. ES-lint. Так, что еще на L? Ну, в общем, придумайте что-нибудь. Может быть, вы будете не первой буквой, второй тоже будет неплохо. Да, и вместе составив какую-нибудь... То есть в прошлом году было очень как бы просто. Мы сказали, кто составит какое-нибудь интересное слово, большое или не очень, тот получит билет на следующую конференцию бесплатно. Ну, как бы столько людей сфоткалось, как бы, что пришлось всю конференцию делать бесплатно. Так что можете постараться напрячься и сделать еще и следующую бесплатно. Все просто. RSCONF, Rolling Scopes или RSCONF 2016. Хэштеги публикуем. И может мы даже что-нибудь, не только билет на бесплатную конференцию разыграем. У нас еще есть майки, только не такие, а синие. И нам надо как-то тоже их разыграть. Так, ну победитель определяется организаторами. Что еще можно сделать? У кого есть ноутбук? О, подготовились. В конце конференции у нас будет соревнование, то есть не обязательно участвовать, можно посмотреть, болеть. А кто участвовал в прошлом году? Ну, отлично. И что значит? И можно выиграть что-то. Саша расскажет, Саша. У нас есть билет на конференцию в Амстердаме по реакту. Да, но мы не оплачиваем перелет, так просто, билет. Хорошо, что не бесплатно.
Ну да, я думаю, всем привет. Все знают Мишу Ларченко, вот он переехал в Амстердам, и он один из организаторов RSCONF 16 апреля, который пройдет. Он выделил один билет для нашего сообщества. И розыгрыш тоже будет прост, просто запостите в соцсеть хэштегом «Хочу в Амстердам», какую-нибудь фотку, не знаю, ну, связанную с Амстердамом. Ну, можете просто, если не придумали ничего, что-нибудь просто зафоткать. Не знаю, вон, да, пиво что-то, вон, вот цветок там. Ну, вон цветок можно сфоткать, не знаю. Ну, и хэштег еще RSCONF и Rolling Scopes, чтобы я нашел ваше фото, прокомментил, залайкнул, что вы в игре, короче, и потом среди тех, кто запостил, что «Хочу в Амстердам», великий рандом выберет победителя. Вот. То есть это будет потом... У меня есть красивая коробка из Амстердама с Ван Гогом. Вот. Мы это... Да, и на лабутенах, и, короче, выберем победителя. Только еще большая просьба: билет именной, это для комьюнити. То есть если у вас есть виза, действительно, есть возможность поехать 16 апреля, и вы действительно хотите, ну, тогда, пожалуйста, участвуйте. Вот. Продать, к сожалению, нет. Я думаю, что если у вас не получается, но вы передарите билет кому-то из комьюнити, либо кто-то был на конференции, мы еще уговорим Мишу этот билет ему отдать. Но продать какому-то там Мише обратно не получится, да. Спасибо.
А где коробка с Ван Гогом?
Ну, она там далеко.
А, да, у нас есть второй поток. Всеволод там один пока. Вот. Не бросайте Всеволода. Так, ладно. После конференции. Конференция планирует закончиться в 7:15, и как-нибудь мы поедем в ресторан «Гаштет». Их два есть, поэтому не перепутайте. Наш на Захарова 31. Там заказан только ресторан. Поэтому то есть все напитки и пиво, еда за ваш счет. Благодарности. Мы очень благодарны целой пачке компаний, которые поддерживали нас не только вот сегодня для подготовки этой конференции, но вообще, в принципе, за год. В этой конференции нам очень помог Google, Mozilla, Яндекс. Они предоставили, во-первых, нам спикеров и даже согласились оплатить все их расходы по транспортировке их в Минск. И огромное спасибо, что спикеры сюда приехали. Thank you. Так, что еще? Огромное спасибо парку высоких технологий за то, что нам бесплатно предоставили такое здоровое помещение. Мы очень-очень рады. Спасибо JetBrains, что снабжает нас уже не первый год бесконечным количеством лицензий на свои продукты. И самое огроменное спасибо ИПАМу просто за все. Начиная от финансовой помощи до помощи в оформлении приглашений нашим спикерам. Так. Ну и компания это как-то безликая. Мы хотим персонально сказать от всего сообщества, я думаю, от всех участников. Это Юлия Лобович. Юля где-то работает, видно. Так, еще одна Юля. Юлия Румянцева, Юлия Лобович есть? Спасибо. Так, а Максим Борисов тут, наверное, нету. Максим? Ну, Максима нету, ладно. Максиму спасибо за дизайн. Так, Саша Карлович, Андрей Волченко, Саша Герасимов, Дима Герасимов, Сергей Патрончик. Есть кто-нибудь? Есть Саша. Саша, спасибо. Вот. Спасибо. Ну ладно, если уже Дима Воробей, то я хочу сказать спасибо моей жене, которая всегда меня поддерживает. Терпит этот Rolling Scopes. Вот, я ее очень люблю. Спасибо. В общем, поехали. Теперь у нас 3 минуты перерыва. Для того, чтобы кто хочет, мог перейти в второй поток. Я переключился на Ингвара. Ингвар? Are you ready to rock and roll? No, thank you. Sorry. But you should be here. Юля, у нас есть онлайн-трансляция? Есть у нас онлайн-трансляция. То есть кто не доехал сюда, могут смотреть это онлайн. Что? На канале Rolling Scopes. Да, логично. Так. И запись тоже. То есть мы сегодня запишем, а потом выложим, только нарежем. И будет плейлист. Так, а еще какие-то вопросы? Да, у нас есть еще 1,5 минуты. Можете пересесть, поближе тут сесть. Более удобное место занять. Перейти во второй поток. Там я рассказывал про фотографии. То есть у нас есть стена вот за экраном. Там будет Женя. Женя ушел? Придет еще. Там можно подходить, сфоткаться. Где-нибудь там и фотобокс поставим. вон, Саша Оргиш. Вот, Виталий Фокин тоже здесь? В общем, если кто-то хочет выступить в Бресте 12 марта, можно подойти к Александру. Вот Александр с буквой И стоит и что-то рассказать. Ну или ко мне тоже. So, let's start. Thank you for being here.
Hi. How's your morning? I'm going to break your brains from the morning, so sorry in advance for that. I wasn't sleepy as well, so probably I'll break my brains as well. It's just that previous times I was giving this talk about just writing bubble plugins and like post CSS plugins and other stuff, and the problem is that in the end of the conference, participants were coming and just asking like what the hell it was, why are we doing that, like, and what it actually does inside, and I decided just I can just give talk about more advanced stuff like how it works inside, how parsing works, how transformation works, and so on. So my name is Ingvar Stepanyan. I work at Cloudflare in London office, and we are doing different real-time transformations on your code. So like the goal is, if you write some, if I write some shitty code and I host it on my website, the goal is that we fix it for you in like real time by just transforming on our proxy. And like we have caching CDN, which also like says the result of those transformations on our servers, and we are protecting from DDoS attacks and other stuff. And particularly, I am just working on parsing transformation, so that's why I'm talking about this topic here. And I hope to convince you that your code is not a string, that you can do much better with it. So, who knows what is source maps? Let's start from something. Okay, perfect. Then I at least won't be explaining what it is. Do you know how it works? Anyone? Okay, 1.5 people. So source maps are just like, initially we had this problem when we were compiling different languages into JavaScript, and we tried to debug them, and we were getting some weird stack traces that didn't give any useful information about like where the actual errors happens. Because whenever we try to compile, actually nowadays, any language to JavaScript, you can compile anything, you are getting a lot of mess that tries to simulate another virtual machine or another language standard library, and it doesn't really give you proper locations in your real code. So whenever any errors happen, you really don't know like what exactly happened, because all the names are mangled, all the locations are screwed up, and so on. So guys at Mozilla initially like came up with this idea of source maps, which are basically just like mappings from original locations of every known symbol in the original code to destination locations. So here you can see like how they look like in the debugger tool. They're basically just like this line transforms to this line and this column. Beginning of this line transforms to this line and this column, and so on. So in that case, whatever language you're using in original, it just transforms to pure text locations from source to destination. And any browser can just map directly like locations of errors that happened to original ones and give you like proper stack trace. So yeah, you just get like, for example, when you were writing CoffeeScript, I hope you don't do that nowadays. And you're using ES6, right? Cool. But like you could get those proper error stack traces. I just identified like up-to-date screenshot with Babel, but it will look just the same. In your ES6 code, you will get proper locations. And the problem is that we are using a lot of builders. Whenever we're using a builder, we are using a lot of plugins, right? We are having a lot of plugins in our pipeline. Doesn't matter like what exactly we were doing. For example, this is code from Umdify, like this browser verify plugin. That do you see any problem here on this slide? The problem is that this plugin, what it really does, it just concatenates strings. So it just takes your real code and concatenates random strings to it. Let's take a look at another like grunt plugin. What it does, it just reads file and again like it just concatenates strings to it. It works on just string. I can write super duper universal transform as well that would just return any random string. And the question is, how the heck is browser going to figure out how exactly your original code maps to this destination if you are having just two strings on two sides? It kind of just guesses that, okay, probably this was transformed into this piece. That just doesn't work. It's because your code is not a string. It actually has a soul, and whenever you are working with this as a code, you need to treat this as such, you know. And you're actually parsing even now. You're not grasping like whatever I'm speaking about. You're not really grasping every single sound impulse that I'm sending to you, right? You're actually transforming that into something meaningful. Or like, probably we could speak by, I could just say, okay, I'm now going to say sound impulse with amplitude 0.7. And you, okay, I understand it. Now sound impulse 0.9, okay? But we would lose a lot of time by just like building this dictionary, and we would have a lot of problems with communicating with each other because we have different voices. Whenever you're reading a text, that happens as well. Like, you're not really like trying to go through each separate symbol, right? You are seeing some structured thing from out of this. Don't try to read it. It's not part of the presentation, just demo. So you look at the code. You see separate paragraphs, right? This is the basic like top-level structure. Then when we are going like deeper, we are seeing separate sentences. We can like, when we are reading, we can just go through the through any like book or whatever, and we see, okay, this is separate sentence. When we are reading a sentence, inside what we are doing is we are splitting each separate word and punctuate. And how do we read them? Firstly, we have this words and punctuation, which we consider like finite blocks of like how we communicate or how we write text, right? We are not really like doing as children do. We are not reading each separate character or whatever. We are just having these words and we are reading them as whole. Then from these words and punctuation, we build some phrases. From these phrases, we build sentences, and like we having, and on each step we are having some finite block, which we can use for communicating with each other, and it has like noun structure that we all share, and like this is common dictionary that we agreed on. And these sentences are built into paragraphs. This is pretty simple, right? Like that's how you listen to me, hopefully, or like how you're reading the text. Now, how to read the code? What really changed? Instead of like sentences, instead of phrases, we are getting expressions in our code. Expressions are just like mass expressions. It can be call expressions. It can be like variable access or whatever. Then from this expression, like initially we have the same words and punctuation, and then from this expression we build some finite statements. Each statement in our code is just like whatever you end with semicolon, or like if you're not using semicolons in your JavaScript, then you're screwed up, sorry. But like whatever is ended with semicolon is we consider a finite statement because it like does something useful. It can be executed on its own, then you go to next statement, right? And then out of these statements, you will build some functions. Probably we even then after that build some programs out of those functions, or probably not. Probably just leave that code and rewrite everything from scratch. But anyway, this is the usual structure that we are using when reading the code. When you look at the code, you're not looking at each separate white space or at each separate dot or whatever. You're just seeing those, okay, this function, it consists with with those statements. The statement contains those expressions, so on. Now, why I'm talking about this? How do compilers read the code? The thing is that they don't really do anything new here. Compilers were built like exactly simulating what human beings do. They just take the same code, they read those functions, like inside of functions they read statements, they read expressions and so on, and they represent it as finite structures that we can grasp, that we can read, that we can transform. Actually, compilers can read and transform. Hopefully I'm not doing that by hand, but with tools. So this is really simple. Like if you figure out this point, at this point, if you understand, if you're not, you can ask me any question, feel free to interrupt. So if you understand that compilers do really the same what you do with your code, or with what you do with books, or what you do with like while listening to me, then you understand how compilers work. It's really not that hard. Like now, in compilers, those steps where they transform text into the structure that they can work with is split into two separate stages. First stage is called Lexing, where it just, at some point you just need to read actual characters into words and punctuators. So this stage is called Lexing. It's split because it builds the very basic stream of tokens that then can be transformed into some structured representation. But even in this stage, it just transforms your input stream into a stream of common pieces of your code. So, and this stage is called Lexing. It produces tokens. Tokens are just pieces of the text that are meaningful. Like all the white spaces are removed, all the comments are ignored, only the meaningful parts. Then those tokens go into actual parsing stage. And parsing produces syntactic nodes out of it. So it gets as an input this array or like stream of token objects. And at the first point, it just produces expressions. Out of them, it builds statements and other stuff. It can work with this array of known pieces of code. Let's see how exactly it works. Okay, just on a simple example. So we have answer 42. We see it as list of characters. We will be trying to simulate parser here. First of all, what your editor does, like any editor, even the simplest one, even if you're using some Nano or Vim or whatever, it needs to read the stuff from the disk or from network or whatever, and it sees a stream of bytes. And actually, even at this stage, if you're thinking that you're not using any advanced builders or parsers or whatever, it actually already parses your code. Because what it needs to do, it needs to parse those bytes, go through them one by one, and collect Unicode characters, which can actually consist from more than 1 byte, right? They can consist like from up to 4 bytes in UTF-8. So even if you are using the simplest editor, you are still already doing some basic lexing, because you need to parse those bytes. Like, okay, we'll parse 3 bytes. Editor can represent this as visual symbol to you. Then it can parse another 3 bytes or 2 bytes or 1. And at each stage, it just needs to represent this to you its visual symbol. Now we can go in deeper, and there are electrical impulses that form those bytes. But I hope that for the sake of our just mental health, we won't be doing that. Let's just look at the string as if it already consists of those characters, and we will be working with it. First thing that we do, we just put some pointer at the beginning of the string when we want to parse it. Like pointer in native languages or in JavaScript, it will be just some I integer variable that points to 0. And we see that there is character v. Now, Lexer has a set of rules, in this case for JavaScript, that tell how exactly we want to collect the tokens. So it knows that if something starts from v, then most likely it will be continued with another symbol that it needs to read. So it puts this into the buffer and continues reading. It goes to the next character. And it sees that it's also a letter. If it's also a letter, it just concatenates it to the buffer, Then it sees again that it's also a letter, it just concatenates into the buffer. So what exactly we are doing when writing a lecture is we are basically teaching the child to read. You know, when we are teaching children to read, we teach them, okay, this is V, say it, V. This is A, this is R, R. Now say it all together, var. This is exactly what tokenizer does. It reads character by character and it tries to combine it into one word and actually put it as one word into the array. So that like it actually picks those words. Next it goes to this white space. And when it sees white space, it knows that, okay, the word is ended. You can like flush that buffer that you collected. Now, it checks this word in the list of noun keywords for this language, in our case JavaScript. So it just looks, okay, var is a noun keyword. If it's a noun keyword, we mark it as such. I just use colors for marking. So in this case, just yellow, right? It's a keyword. Okay, that buffer is ended. Now white space. White space we can safely ignore because it's not part of any meaningful stuff that will be useful for parser, except like actual location where it happened. So it goes to the next character. And again, it just reads A, N, S, W, E, R. Okay, we write the word. Now it again checked it in the list of keywords. It found that it's not a keyword, apparently. So it just puts this as a regular identifier. So token stream already looks like this. We have like one element with type keyword and text var, another element with type identifier and text answer. So instead of just having a huge string that we would try to parse with some weird regular expressions, I hope you are not parsing anything with the regular expressions. No, not even HTML, please don't. But you're using a proper parser for that. So here you're already having two tokens. And again, we stop on the white space, which we know that means the end of the word. We go to the next character, which is equal sign. It knows that if it's just equal sign, there is nothing that will be followed by, well, there can be another equal sign, so it will go and try, but it sees that it's just white space. So it was just punctuator, and it puts it as such into our token string. Then it goes to 4, and again, it knows that after one digit, there can be another digit. So it needs to wait for another digit and put it into the buffer as well. And finally, it goes to the semicolon, and it sees that it's just punctuated. After semicolon, there is nothing that can be added up to it. So it just finalizes. So out of our huge string with different comments and different white spaces, we are having like list or array of tokens that we can work already with. Even when we are doing such simple tokenization, we can already do something useful with this array, because like instead of just doing some .slides.match on our huge string, we can just have array of meaningful stuff and like see, okay, I want to rename all the identifiers. I just go through all the identifier tokens and just replace them in place. That's what simplest editor can do. And it can do this without touching other pieces of like of your code. Now, what more advanced parsers do, like instead of just tokenization, it takes this array of tokens as an input from tokenizer, or it can be just stream if it's doing like pipe transformation, and combines them into something meaningful. So at first, it just assumes that everything is your program, and inside of it is this variable declaration in our case. Now, when it's variable declaration, because it starts with var, so it's obviously variable declaration, it goes inside of it and looks for variable declarators, like separate passes of, like, you can define in JavaScript separate variables with just one var, right? So it needs to take this child, this variable declarator, and put it into another substructure. Now inside the variable declarator, it tries to parse the left and the right side. So it parses the left side, it says that it's just identifier, and the right side is the simplest literal. Are there any questions so far? Just in case. Okay, so, and what he produces is called abstract syntax tree. Why is it called this way is because instead of instead of our original stream, we already got this array of tokens that is kind of helpful. But even in the array of tokens, we are seeing a lot of those semicolons, equal signs. We are seeing different like plus signs or whatever, and they don't tell anything about the actual operations in our code. So what parser does, it just drops all the insignificant information. It just drops all those symbols, and it transforms into structures, into tree that you can like transform to JSON and just pass to another tool, or just save it as is, or do git diff on JSON or whatever. And so yeah, it's clear why it's called syntax tree and why it's abstract, because it just drops all the punctuations and other stuff, but transforms to actual meaningful pieces of your code, actual structures. Now, why is this important? We all were using file-based builders, right? Who use grunt or make or whatever. Everyone did. Okay, almost everyone. So what they're usually doing, like whatever make task you have or whatever grunt plugin you have, they just read the file. They parse this code. Yes, they need to parse the code to do anything meaningful with it. They transform this AST that they got inside of the plugin. Then they generate the code that they retrieve after transformation. For example, they, I don't know, removed all the console log statements in your code, right? They need to regenerate from AST again your code. And they write down this code to a file. Then next plugin comes. It takes this file, this generated file as an input. It reads the file. It parses the code. It transforms the AST. It generates new code and writes into the file. Guess what happens when the next plugin comes? So what is the problem here is we are doing a lot of operations that we don't really need to. We don't really want to waste time on reading and writing temporary files every time. And that's where streaming-based builders came. They decided that like I/O is expensive and we can avoid it by just transforming everything in stream. This is how like Unix pipes work, Gulp plugins work, and who is Gulp? Okay, so yeah, we are seeing how this transformation happens in real life, how we are going from, how we are optimizing our life cycle. And they just avoided this reading and write file. Initially, they just read the file, pass it to the plugin. Plugin parses the code, transforms AST, generates new code, and instead of writing to the file, it just directly passes the string to the next one. And this is huge optimization, right? But there's some problems. One of them is that like we are still doing expensive operations, like parsing and generating code. It's much less expensive than I/O operations, but still. But even this is not that significant. The bigger problem is that what we are talking in the beginning, why we talked about source maps. Still, here plugin receives just a string as an input, and it outputs a string as well. So it knows nothing about your original code as soon as it was transformed by a new plugin. It cannot preserve any location. It cannot like provide you with meaningful error stack traces because it already lost that information on previous pass. So what we can do better here is just move this arrow a bit higher. I literally moved it in presentation, you know, but in real life it's a bit more complex. We can just avoid parsing and generating code as well, and instead of that, we just in our systems that are called transpilers nowadays. That's the way I choose the word, but anyway, they read the file, they parse the code, and they keep track of this AST that they parsed. Every plugin that comes into your pipeline just receives AST, transforms it, and just passes as is to the next plugin. It doesn't generate the code, it doesn't lose any location information because it was parsed initially and it's still there because all the meaningful information is preserved in the original AST, and it just transforms it any way it wants to. This is how, for example, Bubble works. This is how like TypeScript works. And you're just having some plugins that you're adding to it, and they just operate on this AST. And this way, all your source maps work properly, no matter how many plugins you add. Which which tools do this actually inside? Like use AST. In fact, all of them. Anything that operates on your code works with this AST. Like we have minifiers. Uglify.js has internally own JavaScript parser that parses AST, minifies it, and it actually has also, it's not very well known, but it had for many years support for plugins that allow you to transform AST with some custom operations. You have linters. Like we had JS hint, we had JS lint. Initially we had JS lint, right, which just had some strict set of rules by Douglas Crockford, and he said like, okay, this is how you all should write the code. Then some people disagreed, no, I don't want to do that crazy shit, and I just want to, and I just want to do that a bit more simply. And there are JS hint, which just relaxed on some rules and gave some like minimal but configuration. And then Nicholas Zakas wrote ESLint. He decided to go in further, like why we need to wait for the maintainers to add some configurable options. If I just want to change something, I need to send pull request every time, or I need to just live with it. And he decided that instead of relying on someone else to maintain those rules, you can build a linter that's completely pluggable. So ESLint plugins are just functions that again like accept AST and do their own checks. They just go through this structure. For example, you don't want any variable declarations in your code that contain function on the right. So those plugins just go into every variable declaration and check that there is no function on the right. And in ESLint, you're just saying, okay, this plugin should work, this plugin shouldn't work. I just require some new plugin. And it all just works, like without any work from the side of maintainers of ESLint. You can even add your own custom plugins if you know you're doing some weird stuff in your development code, but you don't want that to go into Git or like into production, and you can add some custom rules. You can write them if you know AST. In Babel, you can write on transpilation plugins as well. Like instead of like Elevate just had this ES6 to ES5 transpilations, and now we have this plugin support that allows you again to accept AST and to transform it in its own way, and like combines it with internal transformations together in one pipeline. Another tool that is probably not so well known, but is actually pretty cool, is Facebook Code Mod. Anyone heard about it? No. Facebook Code Mod is a tool that allows you, like, when you're having a lot of legacy code, you often have a problem that it can be written with IE 5.5 support in mind. And so it can do a lot of really, really weird things. And when you open that code nowadays, you just don't understand what the hell is happening inside. Probably you do if you wrote that code, but no one else will. So, and Facebook had pretty similar problem here as well. And what they did is they released these tools, which is like mirror of what they did previously for Python, I guess, which allows you to just patch entire code base with some custom rules. So you can say, okay, I don't support like IE7 anymore. I don't want to wrap every keyword into those brackets. I can just transform all of them into dots, so that code will look simpler. You just write like 2 lines code mod that operates on AST instead of doing like grab replace with regular expressions that would, again, don't do regular expression parsing. It can just go and actually check the AST and transform every single piece in your code base, but the beautiful part of it is that it will preserve any formatting, any comments, any white spaces. So everything will be left intact except of what you defined it to transform. So you can patch your entire code base in just one pass, then you just commit it and forget that you had legacy code at any time. There is not that much popular code mods, because in most cases, as I said, it's just 2 liners that transform something for you, and most people have custom rules. But like from the popular ones, there is official ES5 to ES6 transformers, which allow you to, for example, find all the functions that operate on .prototype.method equals function and just transform this to proper classes. Like, it's much more concise, it's much more easy to read. Also, you can like go through different, obviously, destructuring in ES6 and transform to actual destructuring. And you can optimize your code a lot for other readers by just patching your entire code base. Then any two JavaScript compilers like CoffeeScript Redux, JSX, MScript, and different like there's even like PHP to JavaScript compilers that actually contains full-featured virtual machine for PHP. I don't know who uses it, but it's cool, right? And what they all do is they need to preserve all the original location information. And at the same time, they use different parsers. They use different structures. So what they do is they parse original code in its original AST format, and they just go through it and transform recursively every node to JavaScript node. So after they operate on this original code, they generate this JavaScript AST, and instead of writing into the file, they can just pass it to another tool. And the tool will, like when working on it, it will think that this is originally JavaScript. It's not that different, like it really looks just the same because it's just the same structure except probably more complex, but that doesn't matter. Or like any bundlers, Webpack, Browserify, and so on, they, when properly operating on the code, like Browserify doesn't do that as we've seen like always properly. Sometimes it just does string transformation, but they can just concatenate ASTs and wrap them with some own function declaration, and that's it. You have like your entire module system compiled into just one file. Now, they all do that, but like, how exactly they do this in JavaScript world? I'm just going to go a bit more specific. Some languages have this awesome property that is called homoiconicity. Seriously, I just inserted this word because to look smarter than I am, but I think that it's beautiful property. So where your code is actual AST. Lisp, for example, has it. You just have your code and you can operate it as on data, and any Lisp language can do that. So when you look at this code, you know that it's already a structure. You have like plus operations that contains left and right side. Inside it you have like plus operations, 2 and 3. And it's already structures that you can work with. It's a lot of arrays inside, but still like it's structured representation. It's not just some random code. Or for example, when you have like HTML, XHTML, or like any XML-based language, your code is like AST itself. You don't need to do a lot of like weird stuff. You can just see that, okay, the top node is HTML. Inside we have like head and body nodes. Body contains those attributes and those children, and so this is exactly what we are shown. Like this is structures. It contains like not functions in this case, but like tags with own attributes and children, and we can already work with this through DOM operations. So when you work with DOM operations, you already like transform it AST in some way. And this works well for languages that have this homoiconicity. But in JavaScript, there's one small problem. This is ECMAScript syntax specification visualized with like just. You see these little dots, right? Let me just scale a bit. Oh, I can even SVG. It's not empty, no. I just didn't scroll enough. Okay, here it goes. Here you can see all the rules in ECMAScript specification, how they show how you should parse, or like how browser should parse the code. And there's a lot of things going on. You know, let me just like, and they're all connected in different ways. And this doesn't look that simple as HTML or Lisp, right? Because you need to actually parse all of them, and there's a lot of different names. And if real AST tools would work on this stuff with a lot of weird names like disjunction, atom, character class, class range, and so on, they would be extremely complex. No one would actually be able to build a reliable tool that would produce all of them correctly. So instead, they are built in different parsers that have custom ASTs. No one cares about what ECMAScript spec says. Like, probably browser developers do, but I doubt it. In fact, neither V8 nor like Firefox don't do that, because it's just extremely complex. It's good for writing documents, but not for any like meaningful work. So there's a lot of parsers, like SpiderMonkey Reflect Parse. They invented on like parser API, and it, in fact, like just going forward, became a standard. Esprima decided just to take what SpiderMonkey did internally, and since SpiderMonkey exposed the API, they decided just to implement the same thing. They implemented just the same format, but in pure JavaScript, so you don't need to rely on SpiderMonkey. You can just use any browser that you have. And you can actually build tools on top of that. Not just tools that work inside of Firefox, but actually tools that work like in Node.js, they work like in browser, and so on. Then another guy came with Acorn, and they decided like, okay, we can take Esprima, but Esprima is pretty slow. I can do it better. And he created this Acorn, like 2x faster parser. Nowadays it's not, but at that point it was. And it just shares the same format. So you can see how standard evolved. Then, like, another tool in parallel was developed that is called Uglify.js. You probably all know it. But they decided that that format that at that point only like reflect parse and probably Esprima started to use is not good enough for them, and they just developed own format for ASTs. Tracer, like it needed to operate on ES6. Anyone heard of Tracer, right? By the way, you know, no? Oh, okay. Well, Tracer was the thing before the bubble. It was built by Google, like it was transforming ES6 to ES5, but for some reason it wasn't that popular, and like bubble came in. So what it had to do, it had to parse new things like ES6 specific syntax, and they invented completely own AST. So you can see everyone just didn't care about any standard, as they just developed different parsers in different ASTs. They're all incompatible between each other. They're incompatible with ECMAScript spec, but who cares? Then there were other languages, say CoffeeScript, which had, for example, CoffeeScript Redux. There was original CoffeeScript compiler, and there was rewrite of CoffeeScript, at least attempt before it died, CoffeeScript Redux, that instead of operating on the code as a strings, which in fact what original compiler did, it read CoffeeScript into our CoffeeScript AST, and then transformed to JavaScript AST that was in fact compatible with first 3 of this list. So again, you could just take this output and pass to the tool that accepts JavaScript ASTs, and it would just work without losing any location information. Then we had this thing that called JSX. Like it was created for React that created those HTML in your code, but it's not HTML, please stop it, but that's how most call it. So what they did, they just forked Esprima that started adding support for ES6 features. They forked this Harmony branch and added just custom stuff on top of it. But in fact, all of them like produce JavaScript ASTs. So SpiderMonkey Parse API was the first, as I said, like there's still this wiki page. Now it says that it might be incomplete, please visit another spec. But at that point, it was the only source of truth for anyone. The thing is, like, why it won was because, like, it was the only parser that actually documented its format. That just explains how important documentation is. Because whenever someone tried to transform AST and, like, do something meaningful with it, they Googled, like, okay, parser API or whatever, and they found this page. And on this page, like, every function, every expression, and so on, are, like, declared in pretty simple format, and okay, I can live with it. It's much easier than just digging inside of sources of any of those compilers and figuring out how they do this work. It's much easier when you have like a couple of implementations that are actually compliant with this document, because you can figure out like what is happening, like how you need to read this document, and so on. The only problem is, as I said, like there were different implementations evolving on top of this parse API, and at the same time, like ES6 started. ES6 is a good thing, like, but The problem is that implementations just started implemented differently because PyDeMonkey parser API described everything before ES5 and including ES5, but obviously it didn't describe anything that Mozilla didn't implement at that point, because it was Mozilla parser API afterward. So and different tools such as just implement those new nodes like destructuring classes and so on differently. And tools started to break if they relied on one parser and not another. And there was a need like for fixing it. So Mozilla, Esprima, we from Macon, Babel, like decided just to create another repo for parse API and actually to start working together on figuring out like with what minimal breaks we can fix the AST that our tools produce so that they would look more or less similar and like most tools wouldn't break. But we would at least have document where, again, everything is described, not how it was at the moment. As I said, like documentation is important. That's what we try to fix. And ES3 is actually extremely simple. I'll probably just go directly. Oh no. Okay. ES3 just describes those pieces of your code that I showed you as like structures in JavaScript. In pretty simple way, it's just objects that can be JSON stringified, like passed anywhere, that can be passed to other tools and so on. And for example, for literal, like say it's number, string, regular expression, whatever, like the minimal literal in your code, you have like its real value, like JavaScript value that you can work with, and raw representation, like if you care about quotes in the string, or if you care about like that this string was written, this number was written in hexadecimal format, tools can use the raw part. Now any identifier has name that is properly passed with any escapes and so on. Any like property access, like obj.prop, are represented as member expression, where you just have like, it's easy to read, right? Object property and whether it's computed or not. Computed means like that you are using square brackets with something computed inside. You have binary expressions. Binary expressions are again like very simple. You have left side, you have right side, and you have operator in between. And this is what all of those parsers will produce to you, and you can like work with it with as with any regular object. And I would like just to show you like how we can play with it if we have enough time. I guess we still kind of have because it was shifted. Just to show that it's simple. Do you have any like specific things that you always wanted to implement in JavaScript but it was never here? I thought about like undefined is not fixing undefined is not a function today, but in fact figured that all the modern browsers fixed it already. That's so sad, because it doesn't work as example. But I guess we can, for example, if no other idea, seriously, I can implement anything. What? Sure, let's do it. The guy asked like whether we can pass through as false every time. I don't know why. Well, if you ask me to do that, do some weird API call 1, 2, 3, true, false, and we can see like what AST was produced out of parser. So we have this top level node. That's called program. Let's hide unnecessary stuff. So you can see that in AST actually parsers preserve all the location information that source maps can use, but like for transformations we are not interested in that information, so I just hide it. So we can see this top level program node that contains this expression statement and expression. Like let me just do something to show that it's like if we added some other stuff, we can see another expression statement. And inside of expression statement, we can see that it contains just one expression in this case. It could contain several, but that is called expression. Surprise, right? But names are easy to read, right? There's nothing like very compiler specific that you need to have deep knowledge in compilers to work with it. And inside of call expression, you have obviously like when you read the code, you have like callee and you have arguments. That's how they are represented in AST. You have callee, that is just identifier with our name. And inside of arguments, you have just array of arguments. And yes, here it's a real array, not like in JavaScript. And inside of arguments, you just have a lot of literals. There could be something else, like say if I add just another object, you would see object expression inside as well. And we want to find this literal that contains just like, as I said, like values are just pure JavaScript values. So here it's just true, and raw is just raw representation of it. And we want to find this literal, any literal that contains true, and transform it to false. All the false values, like EST Explorer is really good when you want to just play with it or like prototype Babel plugins or whatever. You can see that false is just contains same things. So let's switch to the transform mode. I'll be using Bubble 5 here, but Bubble 6 like Bubble 6 just broke compatibility. Even in AST, not just with plugins. So I better don't use it at the moment for demonstration. As you can see, the default plugin that is used for transformation, for demonstration purposes, just changes every name to like a reversed version of it. I don't think that's, I mean, it's cool, like foo bar. It's cool, but it's not very useful in our case. So I'll just clean this. And here we see like how default Bubble 5 plugin looks like. It just functions that returns new plugin with name and actual transformations. And in transformations we just put like as keys we put the AST node names. So in this case, if we want to find, as we were shown, like literal, right? We just put literal. Wait. Okay. And inside of literal, wondering where the console will work here. Do you see the console here? Like, is it enough? Let me firstly just log those specific nodes. So you can see that all of them were logged, actually several times, but it's just because I was writing as. So we can see that all the literals are just passed to our functions that we defined here as node. Now inside of node, all that I need to do is just to check that if it's true, if node value equals, strictly equals true, otherwise we will be catching any true value, then we want to change it a bit. And you can see that in output we now have false, false. Like, doesn't matter. Let me just take some init mouse event. I remember this is beautiful API. Yes, yes, this is what I want. Ah, sorry. Ah, no. Okay, I had to save it. It will be quick. Oh, did we change any true to false or false true to false? Okay. I just node value false. Okay, and now we see that in mouse event contains all the false, false, window, false, false, false. Doesn't matter whether we pass false or true. Oh, we can do like the opposite. I mean, it's fun, why not? It's now all true. We can bubble any events. Or we can do something. I mean, it really looks much more readable than previous code, right? Okay, so as you can, we can actually put a lot of more complex transformations, but I guess this is good enough just to show for demonstration purposes. And if you need to do anything more complex, you can again use AST Explorer and use ES3 spec for reading like how those or other nodes are represented and actually work with them. Here I have like Bubble plugin templates that you can use for writing actual Bubble plugins, and it will report all the errors in real time. So you can just use this as base, just fork it or just clone it and work on top of it if you want to write some bubble plugins. And you can use just the same method as in AST Explorer. After you prototype, you can just copy paste the code, or you can work directly there. Doesn't matter. And I guess that's it for now. Any questions? Yep. Do we have another microphone or something? No?
Hi, thank you.
Thank you.
It was really cool. So my question is, we are using Esprima in our project to pass JavaScript, and it seems that it's...
I'll take selfie with you later, okay? You're the first person that uses Esprima in the real project.
Yeah. We are crazy guys. So my question is, what's the fastest solution to pass JavaScript into ST3? And so we are working through the Esprima tree by our hands, by looping. Yep.
Okay.
Yep. And I see how you can do. You just write some. So this plugin lets you not to work into through the Esprima tree via the loops. So how fast this solution?
So you're using custom just traverse through this tree, but you want to use some another tool?
Yep. The tool that you have.
Well, first of all, as I said, you can just write Bubble plugin, right? It works. Well, Bubble 6 doesn't work, but Bubble 5 works on the same AST that you are using in the Esprima. Or there are actually other tools. What?
So I'm just curious, what's the fastest alternative to the Esprima?
Yeah, I think. So if you just want to transform those tools, there is ES tools repository in GitHub. And for example, there is srecurse tool that allows you to just call srecurse.visit and provide actual node types as keys. So it's not like Bubble, but it allows you to already like remove this loop from your code and just use actual node names. It does everything inside.
How fast is it?
It's very fast. I mean, it just traverses object. It does just the same what you do, except that complexity is hidden inside of the library.
Okay, cool. Thank you.
No problem.
Hi, Ingvar. Thank you for the talk. Could you please name a couple of use cases why you are using this AST in Cloudflare? I'm just interested, what do you guys do with other people's code?
Wait, using where?
You've told that you get JavaScript from your customers and you somehow need to transform it in order to fix it or to do some other things. Could you just name a couple of those things?
As I said, it's the goal. The problem is that we currently transform like HTML and CSS, like to fix some common stuff or just to inject some. You can choose, like, for example, you want to inject analytics and you don't want to do that on your side. You just click checkbox and it's already added into all of your HTML pages when they go to customer. Or like, for example, you want to obfuscate all the emails. And you can do that also, like you click checkbox, and we just go through your HTML in streaming mode as it goes from your servers through us to the client, and we just find all the emails and obfuscate them to, like, just write text and JavaScript that will deobfuscate it in the browser, so that like no one can scrape the emails from your website and a lot of stuff. But like for JavaScript, unfortunately, we are not yet here. I want to do that, but the problem is that, as I said, JavaScript is extremely complex in the syntax part, and doing that in streaming mode is really hard, because like if you can do that for HTML because it's just tags and nothing else, for JavaScript you really need to know, for example, if you have a call to the function, this function can be redeclared somewhere in the bottom because it's hoisted in JavaScript. So the problem is that it's really hard to do in streaming mode, and the idea is probably we will be doing that by if you enable caching for JavaScript, we will be just doing that right on our cache servers, for example.
Okay, thank you very much.
No problem.
So any other questions? No? So Ingvar, thank you very much for your talk.
Thank you.
For being here.
And
just 1 minute. And we want to award you from some award. It's like Oscar, but yeah, but just in Belarus, in Minsk. It's not so famous for now, but I hope. Okay, so this is like front-end guy. And so thank you very much, and keep doing your talk.
thank you.